off with medians. Medians are segments that are inside the triangle that connect at the centroid, and they're never outside the triangle. Here you can see at angle A, we have a segment that connects to the midpoint of angle BC. Here you can see at angle C, we have a segment that connects to the midpoint of segment AB. And here at angle B, you can see we have a segment that connects to the midpoint of segment AC. And here in the middle, they all connect at the centroid.
Altitudes are segments that intersect inside or outside the triangle if it's acute or obtuse, respectively. They form right angles, and when they intersect, they form the orthocenter, right here.
Angle bisectors are segments, lines, or rays that intersect inside of the triangle and they intersect at the incenter. And they also divide an angle perfectly in half. So here you can see that angle A is divided by a line, yet both sides are congruent to each other, and it's the same for B and C. And then here they intersect at the incenter.
Perpendicular bisectors are segments, lines, or rays that intersect inside an acute triangle or outside an obtuse triangle to form the circumcenter. Behold, triangle ABC. Here we have one perpendicular bisector. Here we have another one. Here we have a third. All of them form together this one point called the circumcenter. All of these, as you notice, form a right angle right here, and also two equal segments. Each of these things about a triangle has a special property. For perpendicular bisectors, it's the circumcenter of a triangle ABC, shown here. Each one of these altitudes is equidistant from each vertex. See?
Go.
An angle bisector's special property is that the incenter Q of triangle ABC is equidistant from each side of the triangle. So you can see here that all three of these segments are equidistant from each three sides of the triangle.
3. Go.
So there are special properties for the median. The centroid of triangle ABC, shown here, is 2/3 of the distance from each vertex to the midpoint of the opposite side. This is 2/3 smaller than that, this 2/3 smaller than that, and this 2/3 smaller than that.
No.
The special property of an altitude is that the lines containing the altitudes of triangle ABC, shown here, are concurrent at the orthocenter, at orthocenter S. So you can see that all these altitudes are concurrent at orthocenter S, which is shown right here.
In a galaxy far, far away, there was a lunchroom filled with three very rowdy lunch tables. Table A, Table B, Table C. These tables were so rowdy that they had to have a teacher stationed exactly in the center of it. This teacher knew nothing about geometry. Thus, he enlisted the help of two very smart geometry students, Cassie and Joe. Cassie suggested that they find the circumcenter of the triangle. Joe said, well, let's find it using perpendicular bisectors. They all agreed and enacted their plan immediately. First off, they found the perpendicular bisector of segment BC. Then they found the perpendicular bisector of segment AB. Lastly, they found the perpendicular bisector of segment AC. The point where all three perpendicular bisectors intersected is called the circumcenter. Teacher now found the place where he had wanted to stand so badly. And then everyone was happy. The galaxy was saved, thanks to Cassie and Joe.